Okay. Welcome, Kabura Ali. You're new to this, okay. Um, if everyone else here is new, then we will change the route a bit. All right, I'm just trying to find. That is my picture. My video is off to save bandwidth for some of us who doesn't have good internet connectivity. So my name is Enoch, and we'll be diving deep, not too deep, but just exploring what is geospatial or maybe GIS a bit, and some free and open source tools, which some might consider or some people consider not professional, but are actually used for more than professional stuff, and also getting you up to speed on how to use these tools or how to understand them for both personal and institutional development. So without much ado, we can go on. Before I tell you about free and open source software for geospatial, I would first like to throw a quick light on OSGeo. So let's say OSGeo. What is OSGeo? All these might be new to some of us. So I will start from the basics. So the Open Source Geospatial Foundation is a free, open, and self-organizing body, which is global. And what the OSGeo does is to promote and encourage open standards, open software, and tools. Most of them we are going to use today and look at. And membership to this organization or this foundation is open to everyone. You don't need to be an expert or technical person to be part of this organization. So what is OSGO? So basically, OSGO is a not-for-profit software foundation, basically provide organizational, legal, and financial support for project, is volunteer-driven, and promotes adoption of open geospatial technology. Yeah, started way back in 2006. By the way, if I am going too fast, please don't hesitate to put a message in the chat. And if I'm going too slow, please, you can turn on my BPM too, so I can sing faster. Started in 2006, and okay, this slide is based on a slide presentation I did not long ago about OpenStreetMap and OSGeo. We'll look at OpenStreetMap. But yeah, OpenStreetMap started in, okay, I'm speaking too fast. Sorry, I slowed down. Okay. So OSGeo started in 2006, and OSM, which started in 2004. So it's driven by the need to basically organize and then navigate around the growing field of geospatial and open source geospatial, especially because over a couple of years ago, 6, 5, 7, geospatial has been on the trend, and everything we do now is happening somewhere, and whatever we do is spatial as well. So the founding members of this project, if you have idea about GIS already, you might see some familiar names like QGIS or QGIS, some say. And this logo here is the initial logo for OS Geo. So one second, there is someone who is not me. Okay, good, I fix it. So yeah, okay, supporting software development and many others. So there are 25 projects. I don't need to worry you much about what graduated projects and etc. But These are some projects of OSGeo and some in incubation. Some of them might have been graduated already, and a few of them showing their logos. And annually, OSGeo communities meeting for conference and event called FOSS4G, so free and open source software for geospatial. This year it was online, I think last year as well, yeah, because of the situation which is not new to us. And the OSGeo board is made up of 9 elected board members, and because this organization is volunteer driven, it's a volunteer run as well. Charter members, no charter members, membership of OSGeo is open and free to everyone. Be you enthusiast, newbie, developer, activist, or you don't need to be an expert to be a participant or member of this community. And there are charter members. These are community members who decide on who becomes the next officers, board members, and there because 8 million here is OpenStreetMap stuff I was saying recently. I just changed a couple of stuff and I'm reusing this slide. There are local chapters. We don't have one in Ghana. There is the OS Geo Africa chapter, which is really organized a bit by mailing list and meet physically during FOSS4G. And yeah, we still need a lot of participants and membership as well. So at local chapters, they manage translations, documentation, and report at annual general meeting and all other stuff. Yeah, OSM into it again. Around the world. And annually, there is this conference called FOSS4G. It's more than a conference. It's a lot of stuff happening within. And this year it was in Buenos Aires, Argentina. It was supposed to be physical, but it was online. And for last year, 2020, it was supposed to be in Calgary, but it was also online due to condition. And the last physical meeting, which welcomed almost 1,000 participants, was in Bucharest, Romania. Yeah, FOSS4G is mostly covering free and open source software for geospatial, including OSM, and a couple of stuff we'll be looking at today. The video here doesn't want to play. I don't know why, sorry. Regional conferences, that was slide, previous slide was to say FOSS4G is not always about documentation, code, or how do you call it, writing technical stuff, but it's also about, yeah, the fun of it and many others. And these are regional events and global ones happening. And generally, there is a travel grants program to support deserving participants who are not able to support their travel to these events. And these events, there are code and community sprints, meaning that during these sprints, people get to organize and work on related topics, be it cookies or some data collection software, documentation, translation, and etc. This was how many years ago? Mathematics not good, maybe four, no. This was in 2018 in Tanzania, in Dar es Salaam. And you could see lovely people, beautiful people, lovely stickers and food and etc. And if you're a student and you know how to do some programming or have understanding of documentation, OSGeo is part of the Google Summer of Code. You could sign up for mentors and also contribute to projects like QGI. This is for documentation. If you see documentations and want to improve them and so on and so forth. OSGeo is not all in about software. It's beyond that. It's about open source, open data, open standards, open education, and open science. Open standards in the sense that preventing vendor lock-in. When we say vendor lock-in, this is when you have you need necessarily a certain provider software in order to run a certain tool, or maybe you don't need necessarily to have their software or their tool in order to open certain formats of data. For example, we all listen to music or at one point in time are playing some MP3 or MP4 file. You don't need to pay someone to have that's one software to play MP3 or MP4 files. If that was the case, it would really have been very difficult. So that is how come standards are very important to um, open standards are very important to what we do as well. This not yeah, memorandum of understanding. This is not useful. Good. This one is very useful if you are here and you are from the academia, you are a professor, lecturer, or you are working as a teaching assistant in an institution which is geo-related department or have a geo lab. So geo for all is yeah, free and open. So geospatial tools for all. It's a network of laboratories, institutions across the world. The mission is to create research and teaching opportunities in open source geospatial science and build a global open access teaching research infrastructure. So, and also establish a good networking between these. This slide, this picture is from 2017, and you can see them scattered across. I knew there was one in Ghana. I don't know the status now, but when you look at the most recent map, that dot is no longer on the map. So yeah, if you are interested in this, just get in touch with the Geo for All team. Now, this brings us to the tool that we are going to live in for the entire of most of this session. So it is called OSGeo Live. So when I switch slides, I will tell you what is OSGeo Live, but a quick gist is that OSGeo Live is an operating system. It contains most of OSGeo projects and tools that you can use for your geospatial analysis and more staffs, both as an enthusiast, professional, or for your business or any other. It contains sample data, some documentation, and that is both quick start and overview. Overview gives you a brief idea about the project and a quick start. So this is not important. So we switch tables now. If you have any question, this is the time to ask from the previous quick introduction, and then we can now start looking at some more stuff. No question, I believe, then I can proceed. Who here does not have any knowledge about GIS, or you have some? If you have some idea about GIS, or no knowledge about GIS, can you put something in the chat if possible, or if not, that is also fine. So I will go to, I think I have just copied the presentation here. I think I'll use this from Astrid. I can use this. So this is OSGeo Live. So OSGeo Live is it's an operating system. When we talk about operating system, you can see it as the blackboard or maybe the drawing table for a system. Adam has a question. Okay, yeah, he has idea about GIS. That is cool. Thank you very much. So OSGeo Live is an example of operating system. You can see it at the same level as your Android, your iOS, your Windows operating system. So or Ubuntu and whichever you use. And it is based on, you can't hear me? Please, I can't hear you. Who else cannot hear me? My indicators say my microphone is broadcasting something. Who else cannot hear me? Please, if you cannot hear me, just put something in the chat quickly, and then I know, because there's a message in the chat that I can't be heard. Okay, good. One person says they can hear me, so you might want to exit and come back to the meeting room in order to or check your speaker or something. Probably, I think we can view in full screen mode. Photo view. There is no presentation mode. Presentation, yes. Okay, good. So OSGeo Live is it's an operating system, like I was saying, like your Android and stuff. But in this case, it is packaged with software, application software that is suited for geospatial needs, your geospatial needs. And all the software are free and open source, meaning that you can modify what is behind it, you can share it, you can change it. When we talk about free and open source software, sometimes there is the assumption that open source software is porous, is insecure. But not the reality. If you can pay for something, if you are paying for something, doesn't necessarily mean that it's secured. Open source software is also used by most of the closed source software that you use. For example, a GI software that is proprietary might be using a Swiss Army knife of geospatial called GDAL, which we'll look at. So contains this sample data set, consistent overview, and quick starts that helps you get started. So basically, it's a DVD. Nobody's using DVDs to boot systems these days, but it's a USB and a virtual machine. So this presentation I am showing now is running from a virtual machine, and I am going to show you how to make this app yourself as well. So how does software or projects get into OSGeo Live? These softwares can be compared to Notepad, how you have Windows installed on your computer and you don't need to install Notepad. You see, Notepad comes with the operating system being installed. That is how all these softwares we are going to talk about are packaged with OSGeo Live. If you are not getting the difference between operating system or this thing is confusing, please just drop a message in the chat, because I just finished a long presentation and in the end it was that there was a confusion between what is operating system, what is Ubuntu, and that kind of stuff. So if this is also sounding new to you and you're not getting it clear, please draw my attention in the chat as well. So the production of this system is a lot of people, a lot of teams coming together. So yeah, the developers, their application coming in, and it's based on, this is the core. The core is the heart of this system. So the core is another operating system called Ubuntu. So you can see that this is two words. So you can see that there is Ubuntu here and there is L here. So the interesting thing, the funny thing about Linux operating systems, or operating systems that are based on Linux kernel, is that they derive their name from the desktop environment. So an example is that this is running LXD or LSQT and XFCE. These are things that we don't need to worry about now. And the production, documentation, developers, people build and test, and the end it is released. It's put on a USB. They can show it at conferences, and it can be used for workshops. So I can use this for workshop, and I'm using it for this workshop now as well. There is the website, decision makers, and there are projects who are built, and then they also come back here as well. Downloads, downloads from all over the world. So it's a kind of projects widely used globally for both training, research, and academics purposes as well. So OSGeo Live 14, which was released this year, and in honor of Malena, who was leading the FOSSG4 2014 Buenos Aires, but unfortunately passed on. So in this operating system, what do we have out of the box? So meaning that when you pick this operating system and you install it and you try to test it, what do you find in it? Of course, I mentioned it's based on Ubuntu 20.04 LTS, which is long-term support, meaning that this is going to be supported with fixes and a couple of stuff for a number of years. We switched from LXQT to LXD, from LXQT to we switched to LXQT from LXD. In that sense, it's based on Debian, supports QGIS, and this many other softwares built on it. So documentation, some new stuff, and it's in several languages. I am assuming that everybody here is an English speaker, so we are fine. But if you speak other languages and you want the system in your language, you are invited to contribute to it as well. We can go faster a bit. Why is this not showing? Okay, so desktop GIS. Desktop GIS, we will start from QGIS, which is a popular free and open source desktop GIS. We will look at it practically after this slide. There is Grass GIS, which is also here for lot of other interesting stuff for, I think, some raster and analysis. There is a GVSig, there is UDIC. So these are just a gallery of tools and softwares included by default in the operating system that you don't need to install anymore. GeoNode, which is a spatial data infrastructure for managing data set, maybe in your organization, sharing data, both geospatial and web services. If you need to share data with people, GeoServer is the OGC API implementation standard for we know. So WFS, WMAP server, and a couple other of them. I won't go through all this. I will stop here, and then we go back to the system itself and explore. So first of all, we will start with desktop GIS, QGIS. I'll come here. I think, good. So this is GIS, QGIS. So the word GIS is synonymous in a way that products or softwares are using this in the name. So you say, someone might say that, oh, I have GIS. GIS is a broad field. So when we quickly take a look at GIS from Wikipedia, we can see that GIS stands for Geographic Information Systems. So geographic information system. So this is a system designed to capture, store, analyze, and share spatial data. The data is mostly coming in two forms. So spatial data is coming in vector and then raster. So where do we find this? Will not go deep. Wikipedia page is too long. So we'll just look at vector and raster GIS. Okay, I'm doing this because I am assuming that not everyone here has a good understanding of GIS already, or what we are coming to do, so that I don't confuse you that much. So we have the vector model, which is points, lines, and polygons. This is to say that on the surface of the Earth, we are representing objects or elements in this form. It could be a street light, it could be road, pipeline, maybe transmission line. Polygons are used to represent close objects. So it could be a swimming pool, building footprint, and so on and so forth. But these are points you can see, and the lines are connected points. And a polygon is a point, starts from the same point, goes, and then come back to another same point. And then the next data type is raster type. So raster could represent discrete or continuous information. We all take pictures with our mobile phones, and when you zoom in, you'll see that you see some boxes. These are pixels. So raster data is made up of pixels, and these pixels either contains discrete information or continuous information. Some could be elevation, surface model, and so on and so forth. So that is just a quick overview of what data types we can use in a GIS system. So in OSGeo Live, we will start with, I start basically with spatial light. Yeah, and then I'll just drag this data and drop it. So this data we see here is an example of vector data. So vector data comes with attributes. So with this data here in the layers panel, we can go to properties, and then we see some information about this, where it's coming from, the source. We can use the symbology to style this data. Maybe I want to change the line color to red, or maybe based on a certain category. So I double click or right click and go to properties. I can do category, and then I choose maybe based on maybe, I don't know what it is, maybe province is gone completely. Okay. I will use, let me see, populated places. This is just for this city. Maybe let's use natural earth, which is very global. So natural earth is a public domain data set. So I will use natural earth. And then I zoom into natural earth and we can see zoom to layer. Which projection is this? Let's change. Good. So this brings us to the topic of projection, which I was skipping to say, but you can see this is not how the world is supposed to look like. If we have boundaries of all countries or a map of, this is not how it's going to be looking like. But there is something, the third icing on the cake in GIS when you're doing dealing with spatial data, is called projections or coordinate reference systems, can be used to refer to as. So these are definitions. This is a method or standard for defining how data should fit somewhere in the world. So let's say I take a Ghana data which belongs to Ghana and the projection is for Ghana. And then I put that data into a projection belonging to South Africa. What you expect to happen is that obscured polygons or obscured geometry, if it's point, you see some obscured geometry, point lines. So you can see in this case, this is not looking natural. Our brain is not perceiving this well. So because the projection here is for Trento, which is, I'm sure Trento is in Italy, probably. So this projection is not meant for to display data at a global scale. That is a global scale. So this is where this is. So I will just switch to a global one with WGS. You don't need to know this by heart. As time goes on, you are working with this and you will know which projection is supposed to be used for what, depending on your needs. So with WGS84, I can just go for, okay, they have a code called EPSG. So I can go to EPSG 4326, which is for WGS84. So is this one? This is the one I want. You can see the map, small map here is showing the extent. So it's covering the whole. So if I choose this now, we should see our data rendered naturally to our eyes to do. So what can you do with this data in a GI system? This data comes with some information, some statistical or some qualitative data behind it. So you can open attribute table to see what is located behind. So you can see the name of the countries and some other useful information, maybe population, GDP. Whenever you get data from somewhere, this data is mostly going to have a documentation on the attributes included. Not always, but sometimes, yeah, because you are not always going to get a clean data or a ready cooked data for you to use. So basically, I just want to maybe assign some unique color or random colors to each country. This is not looking, so I go to properties, and then I can just go to symbology here, and then I go to categorize. I want to categorize by maybe name. Where is the name? There should be name field. I can type name here and it will autocomplete. Good. So then I click classify. So you see all the countries here. And quickly, this applies random color to all countries in the world. These are some of the stuff. This doesn't make any useful sense though, but it gives you a quick representation of, like, quick idea of what you could use a GIS system like QGIS for. Then we can also say, okay, maybe we want to show the name of the countries. How do we want to label them? So I can go back to properties. That is exactly what it means, labels, single labels. And I want to use the name, of course, and then I click OK and see what happens. So each country's name is not this is now displayed. This is still not looking good because if you maybe you want to make a map and print it on the wall, this is maybe too shouting or too not cartographic, but it doesn't matter. We are getting used to it or trying to explore what we can do with this kind of tool. Maybe, okay, the black on these colors is not looking good. We want to make it stand out a bit. So sometimes maybe you want to add a halo, or it's called a buffer to the sides of the text. So I click draw buffer, and then I click OK to see. Then we can see now that we have a white border around the text, which is black, and then we are seeing some information. Let's say, okay, this is my first time trying how to use a GI system, maybe trying to make a map, fancy map, and then we want to share with our colleagues and say, oh, look, I made a map of the world with the country names. How do you make a map out of it? So in QGIS, it's called print layout. So with print layout, I'll just call the bad map. I'll just call it a bad map. And then it opens up a new window. This window is called the print layout. This print layout might be tiny, useless a bit, but this is the interface that you use, the same interface that you can use to produce maps that you can sell, maps that will be very informative because the end, every GIS analysis, the end product of most every GIS is a map in the end, but you will need to do some analysis and then produce this map in the end. So let's say I want to add what do I want to add? I want to add a map here. So first thing is when you leave the mouse, the cursor on each tools here, it tells you what they do. And then I just add a map here, draw a map on the canvas, and this is render map. Quickly, I have this. I can easily add a north arrow. These are basic elements of a map when you produce a map. Maybe I want to add a scale bar, and then what else can we add? Maybe we want to add a title. It's a map of the world. So I add I just draw here, and then in item properties, this text here can be modified. So I can say map of the world. This is very tiny. I want to increase the font size. If you have a mouse, you can scroll on this font and you see that it's going to increase the font size accordingly, but you can change the font type you want, Ubuntu, if you want it light, you want it medium, whatever, it changes it. If you want to position it to the center, to the middle, and then when you drag this object, you see some guides appearing. It shows you if this is centrally aligned or something. And then sometimes what else is needed? Maybe, yeah, data source. We didn't produce this data ourselves, so we want to add a data source to communicate to whoever is going to read this map that this is where the data is coming from. The same way you add a text, and then you can add a data source here. So data source, where is this data coming from? It's from natural earth. You can see from natural earth data, and then I have this here. I can position most of the stuff I might be doing. I'm doing now doesn't look good. They are not perfect, but as this is to demonstrate to you that what are the stuffs you can do. Some of the stuffs you can do, they are basic, even maybe not even near the step of a basic, but there is more that you can do just to show you the capabilities of what you can do. The next thing that I'll add is maybe a legend. Sometimes we see a map, the legend or the key is the first thing you see, but this legend is too long. So I'll delete it for now. We'll try something else again. And then I want to save this as a picture. So I can go to, I think it should be Atlas. No, this is file, yeah, layout. Then I can export as XVG, PNG, image. If you are a designer, maybe you like SVG because it's vector, then you can export from here and then bring it into your software, maybe Inkscape, Adobe Illustrator, and yeah, Affinity Studio, any other software, and then I'll try to polish stuff. So yeah, maybe you are a designer and then you need to make a map, something geospatial, geographically referenced. You can easily start from a GIS software like QGIS, then export to SVG, bring it into your system now, and then now start working. But if you were to do maybe coloring of these polygons in Inkscape or Illustrator or Photoshop, imagine the amount of time it takes you to fill all of them. So I can quickly export as PDF and I'll just save it to the desktop. It's called bad map and I'll save it to the desktop. Now, when we go to my desktop, we should see a PDF here called bad map. If I open it, you should see this map. nicely presented here, and it's in vector form. Vector meaning that if I zoom in, it doesn't get pixelated. So you don't see pixels. I can zoom in. It has an infinite zoom level. I have over zoomed to 5,000. I will just come back. Yeah, so you can see that you see for a raster, that is a picture, like a selfie you take. When you zoom in, you start seeing some squares. Any question before I keep going on? Okay, so let's look at some basic and useful styles as well. So we'll look at some operations, some quick operations. So let's say I don't need the entire world. So I don't need the entire world. All I need is, I need the boundary of Ghana from this, or maybe I only need countries in West Africa. Yeah, this is something that you will do regularly. You need only data based on certain criteria, like you are filtering. So we only want to select countries from West Africa. So how do we do this? So with selection, so over here you can see we have select features by value, by other means. Expression is one cool one. It might be looking horrible, but first you will need to understand your data in order to select by expression. So we want to select countries in West Africa. So let's see which of these columns here defines uh, the region, say West Africa or something. So I am looking, okay, we see something here. We see region, continent, region, UN. Okay, we see sub-region. So sub-region, I see, let me see if I see West Africa, Western Asia, Western. So we have West Africa in this sub-region. So if we want to filter, we want only countries for West Africa. It means that we will have to say that, give me objects. So objects that are having sub-region equal to West Africa. I hope that makes sense. So we need, if the region, sub-region is not West Africa, I don't need it. So we can filter that way. And this attribute table is just like your spreadsheet. Database is mostly a spreadsheet, or every attribute table is a spreadsheet showing you columns and rows. You can export this into another format. Maybe I can export this to maybe a spreadsheet format. So you can see CSV, Microsoft Excel, and other formats. So when you export it, you remove the geometry, which is showing the lines. So now in our case, we want to select only countries. So I will select by, maybe I'll just use value to see how it works. So values, how do we do this? So the column we are using is called sub-region. So it should be here. And then as soon as you start typing, it should pop up available value. So we want West Africa. And then when I select, it selected 17 matching features. So we can tell that this is West Africa. And then I zoom to selection, I now close. So now let's say I want my friend in another department, or my project that I'm working on, I need to have data on only West Africa. Or maybe somebody says, oh, I want only countries in West Africa. How do we do this now? Data management. I want to save this. So I can just right click, then export. And then I save as, we'll save everything, but save selected features. We'll only save the ones that I've selected now. So save selected features. So your friend might say, okay, I want a geo package. I want a shapefile. I want a GeoJSON. These are various formats that have geometry attached to them. CSV doesn't have, but it can store the latitude and longitude, and you can bring it back. But we want a geo package. Then we want to save it to our desktop again for now, and I'll call it West Africa. Just West Africa. In GIS, we don't like, GIS systems don't like space, or computers generally don't like space. So if you are naming files, try to avoid spaces. So instead of using spaces, try to use underscore, which is a best practice. So I will, when you check this option here, when it's saved, it's added to the map. So I want it to be added. Now I can disable the other layers, and you see if I zoom to layer, this is only in West Africa now. So West Africa, I can now maybe choose some symbology, simple one, maybe gray, and then I do the. If you want to go to the menu is properties, it's the same as double clicking on it, and then yeah, I can now send this in an email or whatever to my friend easily. The same way I can produce a map of it as well. Any other question? Any question before I keep going? I hope this has been useful in a way. If not, just put it in the chat and tell me, then we can change the topic a bit or change the direction a bit. So I think QGIS we can never be done with because there are endless opportunities or things to do here. The next thing I would like to demonstrate or show you is getting data. So these data sets here are packaged with this OSGeo Live ecosystem. But let's say you need data on roads or maybe bus stops in Accra or wherever you are. Sometimes you have to go collect data, but if you are planning a data collection, it is always interesting to know what is out there. You have to search out to see, oh, what has someone already done? And then what can you grab and then build on it before going to the field? Or what can you find? As I am an OpenStreetMap contributor and I know about OpenStreetMap, I am going to quickly jump onto OpenStreetMap. So we'll talk about OpenStreetMap and then look at how to get data from OpenStreetMap and then put it into our GIS and try to create a more reasonable map or something from this data. So we go to OpenStreetMap. So OpenStreetMap is a community, it's a project, it's a database. So it's run by volunteers as well. People contribute to OpenStreetMap all around the world. When we go to openstreetmap.org and quickly I search to, let's say I go to 37 Military Hospital. I just go to 37 Military. Let's see, there's no only one 37 Military in the world. There are many others. So I'll just limit this to Ghana and see what happens. So it doesn't show. Okay. Military hospital. Good. So you got me here. This is around 37 military hospital, and this is OpenStreetMap. Now with OpenStreetMap, the advantage or the benefit you have is that this data here is not owned by one person. It's owned by everybody. So you can also contribute. Maybe there is now an ATM here. So passing by, you see that there is an ATM in now 37 block, but it has not been mapped. You can also map it. And this data becomes public property, becomes everybody's own to use. And all everyone needs to do is that when you get data from here and use it, you attribute. Now, vector data in Ghana or across the African continent is hard to come by. I don't know of any go-to special infrastructure in Ghana where you can get a detailed information, maybe information on road network or bus stops than OpenStreetMap. So how does OpenStreetMap work? You need an account in order to be able to add something. Since I already have an account already, I'll just log in and demonstrate. So let me see if I recollect. Good, I am logging. And then in OpenStreetMap, we have editors. So editors are tools you can use to edit. It's the same thing that keeps repeating everywhere. You need a software to do your Word document, right? You need a software to open a link, a browser to open gmail.com, something.com, osm.com. And these editors help you to modify, add, and edit data. The same way in a GIS system, we are changing data here, we are doing something. I can also delete from here. This could also be considered as an editing environment, but it's made for a certain purpose. So in OSM, there are tools. So one of them is ID and one is GeoSM. But the basic and quick to go one is GeoSM, is ID, which is a basic, not advanced. When you start it for the first time in a new browser, it gives you a walkthrough. You can see a walkthrough, but we will edit now. I have idea already about this. So it presents you with some layers. So you see some lines, some points, some polygons somewhere, they are having some meaning to them. And then you see a picture behind. So the satellite image, it could be a drone image. This is the raster. So if I zoom in, I keep zooming in into this now, you see that it becomes, I see some, yeah, let's give you all, we all zoom into our pictures, or we have at the point in time, zoom into a picture and we've seen pixels, but I've overdone this now. Go back, too much. Okay, so I will just, so with ID, if you don't zoom in, you don't see the existing data to modify. So you see I've over zoomed out, and it shows me an overview of what is there. It's black, but I can't add anything now. So the editing control here, which is up here, becomes inactive. I'll just zoom in so you see what has become inactive. So I click this and it zoom into an extent that I can see existing stuff. But notwithstanding, at this scale, we still don't see buildings. So maybe you want to trace a building, you want to digitize a building from here. It is not safe. So you still need to zoom in because there are stuff that are hidden. It tells you, okay, it tells you here on the status bar here, it shows you see 471 hidden features. You know, you can click that and pop something about when the more you zoom in, the more details are revealed to you. Now, all these elements has attributes, and then we can see who mapped this or who added this when and at what time. So you can see this was mapped by, this is the version 13, meaning that it has received 15 changes. And we can see the entire history. And then we can see when this was first added. This was first added in 2012, 9 years ago. That is how OpenStreetMap is working. But now, I demonstrate to you. So maybe this is a shop here, or you know that this is a shop close to you. I recommend that if you want to map, you start from where you know. You don't map remote, and there are resources to help you get started. For example, Learn OSM is it's a tool I recommend. It's a resource, a training resource that I recommend to take a look at if you want to get started with OSM, ID, and getting started as well. So yeah, this building here, I know this is a building, but I can't tell what is the use case of the building. Sometimes there are issues with offset. You see, oh, it's like the road is off. You don't have to now go and move all these things and trace them. No, don't do that. You have to look at a couple of other things before you start moving existing object. But I'll just demonstrate how to digitize something. I click area, then I click one, move the mouse, leave it, I don't press and hold. Click, I just click and it starts making a polygon. And then on the last one, I double click. And we know that when the builders are constructing, they use what is the name of this? The spirit level and this angle square stuff to make sure that at the edges, at the corners of the buildings, is 90 degrees. So I do this and you see, it quickly makes it squared. Control Z to work here and do, and then if I show you is this. Maybe it's a round building. You can right click like a heart, that kind of stuff, and it makes it round for you. So what is this on the surface of the earth? What is this? So after doing this, and it's useless. This could be a football field, this could be a swimming pool, many other features. But what is this on the surface of the earth? What is the primary property of it? We all have a basic attribute. That is, we are all humans. So what is this on the ground? What is it? Building. Building is not the name of it, but that is its feature type, what it means. What do I mean? I am a human. That's why I'm speaking here. I'm able to click. So it's a building. So I just set for building. And it's a general purpose building. OSM, general purpose buildings are represented with, when you click on this start building, yes, you don't need to worry yourself about this now because as time goes on, you'll be able to understand. But if you also need to get data from OSM, you will need to understand the methodology, the tagging system used, how attributes are defined, like the way we saw from, I can close this now, like the way we saw from this attribute table, this here, we can see here. So in the end, those tags becomes the columns and the values here. So the keys, that years will become something in the box here, and the building, which is the key, becomes the column, and the values becomes the detailed definition of what they mean. So this is a building, and then I can easily save to OSM. So when you click upload, this is to demonstrate. You don't just map one building and you save. Map one building and save. You can do a couple of them before you your upload. So when I click upload, I need to put a change set comment. Comments describe what you have done. So all I did was I added a building because I have used this before. It will pop up here. So I added building. I'll say Africa Digital Skills Conference demonstration. Yeah, as part of Africa Digital. Okay, okay. I added building. Just okay. Sometimes you might be wondering if what you did is right or wrong. So you want to check. This boss here said, I like someone to review. It doesn't mean that this doesn't get saved in OSM. As soon as you change, it gets saved. But when you click it, it helps others to review your changes. So I upload, and quickly this takes a few seconds and is in OpenStreetMap. So I can view now. Yeah, it's here to be rendered. I will just have to wait. Rendering means that displaying it. That is what rendering means. If I refresh and clear cache a bit, maybe it should pop up. So that is how OpenStreetMap works. So now, how do we get data from OpenStreetMap? So the easiest or the go-to place where you can get OpenStreetMap data from will be GeoFabric. GeoFabric download. So GeoFabric is a company in Germany which offers services around OpenStreetMap, and they also provide a download server which generates extracts of OpenStreetMap data as shapefile and zipped tar file for the whole world based on region or countries. So this extract is done, I think, on daily basis, 24 hours. So in Africa, I can get the entire Africa here, but we want to grab Ghana. So this is Ghana here. The latest, what is the shapefile? This is the free shapefile. Is this one? It was this file was last modified 8 hours ago. So I think after every 24 hours, that was at what time? That to have been maybe probably midnight. So this is having a continuous job on it, which is running every 24 hours. So I can now grab shapefile is one format in which data is soft spatial data is saved. So I click this, it's downloading. It will be done in a few seconds. 3, 2, 4, 1. So as this is downloading, GeoFabric is place to go to get OSM data. But within QGIS, which is a tool for working with geospatial data, we can also get OpenStreetMap data directly, but not on bigger scale, small scale. Let's say we are working in around 37. So there is XYZ tile here, which is OpenStreetMap, basically. So it gives me a base map, background that I can use as a reference. So I quickly zoom into around, let's just keep zooming. I come to, where is 37? Blah, 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 blah. Okay, good. 37 should be here. Good. So I want only roads around 37, just this area here. So with the plugin called Quick OSM, which is QGIS is open source, and it has an API, an interface for Python. So if you know how to do something with Python programming language, you can write native plugins that use QGIS interface to make your workflow easy. So maybe you are doing something which is repetitive, or the feature is not in QGIS by default. You can put together this yourself as well. So the Quick OSM plugin, which I've already added, there's also an interesting plugin called Quick Map Services, which allows you to add do upgrade plugin just quickly. Good. So which allows you to add base maps. This allows you to get data from OSM. So you can see the definition, download the data thanks to Overpass API. So it's using a tool called Overpass API. So if you are not within QGIS and then you want to be able to just extract some specific data from OpenStreetMap, the tool is called Overpass. So this Overpass tool can help you to extract specific data. So for example, I just go to Accra. Accra, it is not Accra. Accra, Ghana. Good. So we are in Accra, Ghana here. And then let's say I want only what features are very of interest to us. Maybe I want hospitals in Accra. or maybe pharmacies in this extent, not the entire Accra. The extent to focus on is this. If I need the entire Ghana, I will need to define that. So I will do a wizard. Then this also has a bit documentation. So you need to understand the tag, like I was saying, building something, something. So pharmacies will be, okay, I focus on, I'll use filling stations. So filling stations in OpenStreetMap are defined by the tag. Amenity is equal to fuel. So this tag here. So when I type that and press enter, it runs a query and it runs it in the bounding box. So B box, which is this area here, and tells me some summary here. If you can see, I zoom in a bit so you can see larger. So it tells me it has found 35 nodes, 2 ways, 27 POIs, and then 2 polygons. So it tells you that these 35 nodes are nodes at each corner, and then these polygons are complete polygons, and the POIs are points. So you can see the polygon, the point. This is a point, is a node. It has 5 tags. This is the ID in OSM. If I click on it, it should pop up. You see who mapped this, and then you can see history, when it was done, when it was first mapped. The first time it was mapped was by someone. So OSM, in OSM, you don't necessarily need to know the name of something to add it. So you could see 7 years ago, someone mapped this, and then all the person did was to add the basic attribute, the basic tag, that is a filling station, fuel. You don't need to type that filling station. And then after 2 years, then someone added the name and the brand, you see? And then after how many years again? Maybe 4 years later, someone came to, I think, change something. What happened? What was changed? We can't, maybe it's the geometry. It was moved from somewhere to somewhere. And then next, somebody also came to add a Wikidata something tag. So this tag, which is pointing to Wikidata, which is a knowledge base for connected to the Wikimedia ecosystem. So this tells you that, yeah, this is affiliated to a Total Energies or something like that. So back to Overpass here, so now with this, we have data on all filling station in this extent. There might be others, but because they are not in OpenStreetMap, the query is not returning it. So someone might be asking, why all these things about OpenStreetMap? Why can't I do this thing about Google Maps? Google Maps has details. Google Map is from Google, is trusted. No, that's a very wrong assumption. The thing with OpenStreetMap is that it's a community, it's a database that is owned by everybody. Google Maps is for Google, and Google will care about where they are of interest into. Now, we can zoom into your village. Google is not interested in your village. There are no hotels in your village. Maybe there are no big or 5-star hotels in your village. Google is not going to map your village. But let's say you need something to do with your village. You want to make a representation of your village. You want to do an analysis on, oh, okay, we want to plant trees along the street. If this road is 6 kilometers and we want to plant trees every, how do you call it, 500 meters, which positions can we plant the trees? Where I know maybe sometimes there are buildings along the street. So you want to do a spatial analysis in the sense that, okay, wherever there's going to be a point, it should not fall within a building. It should fall within a place where there is open space. So you, in the end, you will see that, oh, along a 6-kilometer road, you're only having maybe 20 trees. It might be 2 less or 2 more, but 20 trees could be planted. Rather than now you go out, then you start to find out that, oh, along this street, all the streets, roads, buildings are built everywhere. So you can't plant those number of trees you have already bought. So with spatial planning, you have a one step ahead of what is ahead before you go out there to do whatever you want to do. So with this data, I can export as a GeoJSON, which I can load. I can export as a GPX and put in whichever software support it. KML, I can put it in Google Earth Engine or other supported platforms as well. So that brings us back to QGI. So now we want to, I think the data for Ghana should be done downloading from GeoFabric. So I'll open this. It gives us a shape file, a zip file. I'll just extract here, and let's see what is in it. So A shapefile is not just one file. So shapefile is made up of three files. I'll switch to list view so we can see what basically I'm talking about. So if you look at this one, is having the same name from here to here. Do you see? Oh, I need to zoom in again. Why is it too small? I go to view. Let's see, view, edit preferences, and then display. I can change list. Small icons. So let's see if this works. Yeah, good. So if you look at this, they have the same name. So a shapefile is made up of several files, and each of them stores some information. This is storing what is this storing? This is storing the spreadsheet, the attribute table I was showing. This is storing the attribute. This is storing the projection that this should fit exactly in the world where it should be. This is storing the shape, that is the geometry. Is it a point, polygon, those curved ones? And this is storing the index. So quickly, we'll go back to QGIS here, and then we will try to explore. So in the QGIS here, we have Explorer. There are several ways to load the data. You can come here with the data source manager, and then this is a vector data. So we can go to vector, and then we click this icon. In downloads, there should be downloads. Where is download? User and downloads. We should have all this here, but we can limit this to shapefile. We want the data type to be shapefile. So you see, it shows us only the shape, not the other ones. So I want to load all of them. Let's see the data we have in OpenStreetMap and on Ghana. Good. This is a lot, but it's very tidy because there is still more to be done in Ghana. So I will disable hide all layers. So in your GI system, when you are working with data, you want points to be up because if they are below the polygon, they'll be hidden. So I'll just select all the points and then move them up. And then next, I want the lines up, and then the polygons can be there. So we can turn on, let's go for railway. Let's see, in Ghana, do we have railways? Okay, I think probably we have some railways. So let's say railways, and then I want to change it. I'm not seeing anything, so I will change it to just this fancy default tutorial, and then I zoom into this layer. So I put OSM in the back again, and you can see that yeah, we have a railway line from Sekanita Kradi all the way through Takwa to somewhere. I don't know if this is still functional. The last time I was in Takwa for 4 years, this was not working. So, and then there is one here in Accra. So you can see perfectly that this is data from OSM. You can see it's aligning a bit. Now, let's say I want to do that kind of transparency just to switch between. How do we do that? In QGIS, you can go to properties, then you go to legend. Where is legend? There should be legend here, legend. Then we can add a opacity slider. And then below here, you can see that there's a slider here. And then you can see the blend between this color is not a bit, it's not shouting. So always, instead of going to properties, you can use the what is the name of this? Not showing the styling panel, which pop-ups here, and it applies styling on the fly. So I can use the red line or maybe a more thick one. Yeah. So you can see this is consuming too much. The railway line. Good. And then we have buildings. Probably it should be here. Buildings. Good. A lot of them. And now we can see that, okay, it's too much. This is the entire Ghana. But with support of donor partners and OpenStreetMap community working, there have been some areas in Accra that are detailed, like have a good mapping. Like, for example, this is Akwetema, and then Nima down here, Alajo, they have some good data sets. So I want to see what is here. So I want to be able to just get only data in this area. I want to clip. So now let's look at some basic process. I want to clip. I want to get only this. I don't want the entire Ghana. So let's first create our first layer, polygon layer. Let's learn how to create maybe a shape file or geo package. So I want to create new geo package layer, and then I'll call it area of interest. Normally you can just say AOI, and then this should be polygon. I call it AOI. The table name should be AOI. I just put it in this projection is fine. I don't need any other details. And then this is added. Where did I add that now? Okay, it's here. Good. I put it just below this one. Now there is no layer. When I do show feature count, you see that there are no layers in this. There are no features in this layer, so it shows 0 here. Now I want to add be a circle, like a circle or something, rectangle, or just add a polygon. How do we? So in order to add something to a layer, you need to edit. If you want to modify your Word document, you need to open it. And then sometimes if you get Word documents, you can't modify. So you need to turn on edit mode. So I click this, and then I want to add a polygon. So it shows your polygon here. I just want to add something around, maybe this, and then somewhere around here. And then on the last one, I left click, I do the, that is a right click. So I just click OK. And now you see we have a polygon here. I don't want it to be filled. I put it just as an outline. Then I can save and stop editing. Now, with this, I can extract the data of the building data in this extent. I can clip it to just this area by doing vector. Where is vector? Vector geo, it should be geo clip. Yeah, geo processing clip. So the input is what you want to cut, and then um, the the overlay is the cutter, like the cookie cutter, or maybe you pick a tin or a can and you dip it into cake. You see that it makes a pattern there. So the can is the AOI, the area of interest, and then the how do you call it? The data is the input. So I put which data do you want to put now? We want to put buildings. So which is where is building? I can, oh no, not the polygon. Yeah, this input, the overlay layer will only be polygons, but the input layer can be any one. What is GIS building? Why can't I see it? It's GIS OSM and then B. My mouse is not, I don't know why this is. Okay, I extend this and then input. It's at the top. So I can save it to file, save it to geo package, or I can do a temporary layer in the sense that it's only saved in RAM. It doesn't get saved on the computer. So I click this and we have only in the building for this area of interest. So if I turn off every other stuff, you can see that we only have the building for this area. Turn on OpenStreetMap 2 again. Oh, where did he jump here? Go back here. Turn off OpenStreetMap. So you can see it's just here for us. So maybe I can just create a quick representation of the extent of buildings that have been mapped. But this is still not making enough sense. So let's say I want to see what is behind this data. So what is behind it is that what is the attribute? I open it and then I see there is a class building. Let me see. So where did my screen go? 1 second. I don't know where this ran away to now. Okay. I don't know. My virtual box just closed. I don't know if I press a key or it closed unexpectedly. So like I was saying, I was running from OSGeo Live, which is a geospatial toolbox with all these tools, QGIS and other ones. You can use GeoServer, anything. Force and geospatial, you can find it in this toolbox. So I just go back to Control F to make it full screen so that we are good. So I'll go back and then 1 second. Can you confirm if you can still see my screen? So in the end, we have been able to look at not so much, and Always Your Life is just an enabler to all these tools that are accessible. For example, which QGIS that we have used mostly, and there are some sample data included already and coming from OSM that you can use and also play around with for both personal and then institutional development. As I always keep repeating. So thank you for joining, and then without much, I would like to stop here, and then if you have any question, they are welcome. Thank you, and have a great session of the conference.